Chapter 6, Part B, we are going to work on inequalities and systems of inequalities. So day one, we're going to just work on graphing and solving linear inequalities, which will be pretty, it's actually a precursor to linear inequalities. So it should be a lot of review. So remember, these are the symbols for inequalities, okay? An inequality means that it's not equal to. It's either greater than or less than or greater than or equal to, or not equal to. So these are all of the symbols right here for inequalities. Okay, so most of our equations are like 2x plus 3 equals 10. Okay, so they're equals. These are inequalities. They're not going to be equal. They're going to be greater than or less than, or greater than or less than or equal to, or not equal to. So much like in a regular equation, the solution is any value of the variable that makes it true, okay? Just like we have done before. The difference here is they're not usually just one single answer. So here's some other background information that we need to recall. So what happens if you have an inequality like 5 is less than 11? And what happens if you add or subtract a number to a true inequality? Well, if you add a number, we can see that 9 is still less than 15, so it's still true. If you subtract a number like 3, then you still have a true inequality. So if you add or subtract a number to each side of an inequality, it's still true. Okay? So when we're solving an inequality, if we're just adding or subtracting something to each side, then we don't do anything. It's still true. But this is not the case when we multiply or divide, okay, by an inequality. So look at this inequality that we started with before. We have 5 is less than 11. If we multiply by a positive number like 4, then we get a true inequality, okay? But if we multiply by a negative number right here, then we do not get a true inequality. Because if we multiply by negative 3, we get negative 60 on one side and negative 132 on the other, and negative 60 is not still less than. So what happens here is if we multiply or divide either one by a negative. Positives are okay. But if we multiply or divide by a negative number, we have to flip the inequality to make it true. Okay, so let's practice some of this solving we just talked about. So in this first example, in order to solve this for x, I would just divide by 3. And when I divide by 3, it gives me x on the left side. And when I divide by 3, it gives me 16. Okay? I don't have to flip the inequality because I divided by a positive. The only time you flip is if you multiply or divide by a negative. So now how do we graph this? Well, on a number line, I am graphing all the solutions where x is less than 16. Well, here's where 16 is. Here's a number bigger, here's a number smaller. We always include that on our number line. We do not need to go and include 0 on our number line. We just need to have the key numbers. So where are the numbers less than 16? Well, 15 is less than 16, so is 14. So these are all the numbers, okay, all of the solutions, because also 15.5, 15.9. So it's all of these numbers up to 16, but does not include 16. So instead of putting a circle there and coloring it in, we leave it open when it is less than or greater than, and it does not have an equal with it. So again, this should be review, but we'll go through a few of these together. On this next problem, when I'm solving for D, I will have to multiply each side by 7. Again, I'm multiplying by a positive number, so that gives me negative 21, and I don't flip it because, again, it was multiplying or dividing by positives. It's only when I multiply or divide by a negative that I have to worry. So now I have my solution. So again, I want to graph all the values or show all the values where D is less than negative 21. So again, here's my negative 21. A number bigger would be negative 20. A number smaller would be negative 22. So I am going to put a circle at my key number right here, but again, I am not going to shade the circle in unless it has a negative with, or sorry, an equal part with it, and it does not. So all of the numbers that are less than negative 21 are always going to be to the left. All the numbers greater will always be to the right of that key number. Now this changes if your variable's on the other side, so you have to be careful. And then this example right here, what I have is to solve, I have to divide by negative 4. So again, I'm going through these fairly quickly because this should be pretty simple basic solving. But when I divide by a negative 4, that still gives me x here, it cancels out, and it gives me a positive 4 on the other side. But I divided by a negative, so I have to take the less than symbol and flip it to greater. So now again, my key is at 4, so I need the number 4. I need at least one number bigger and smaller on my number line. So I, again, will not shade that circle in because I am only looking at the values that are greater than 4. And those will be over here because 5 and 6 and 7 and 7.2 and all those other numbers are on that number line. Okay, so let's see if you can try number 4. So pause the video. It does get a little more complicated, but pause the video and then see if you can get the correct, not only answer, but also the correct graph. Okay, on this problem, we simply multiply by 7 on each side. So we are not going to flip the inequality. It's going to stay the same. Now, the problem here is I have negative x, or this is like having negative 1. So I am not done. I have to divide by negative 1, and now I will have to flip the inequality to make it from less than to greater than, and this becomes negative 21. So make sure you're understanding those pieces and not forgetting that if there's a negative in front of your variable, you still have to finish solving it, and you can't just ignore it. So now again, I will put my key numbers on here, and that would be negative 21, one bigger would be negative 20, and one smaller would be negative 22. So I put my circle. I am not going to shade it in because it does not have an equal with it, and I want to graph all the values that are greater than negative 21, so they will be to the right. Okay, here we get into solving two-step inequalities, and meaning there's just more than one step. And actually number 4 ended up having 2 steps as well. So in this question, again, our goal is solving for y just like we do with all of our equations. So the first thing I'm going to do is add 4 to each side. Again, adding and subtracting does not flip the inequality, only multiplying and dividing by a negative. So here's what my result is. So now to solve it for y again, to get y by itself, I am going to need to divide by negative 18. And so now this cancels out and I get y. Notice I divided by a negative. If I multiply or divide by a negative, I have to flip the inequality, make it the opposite direction. And 54 divided by negative 18, I believe, is negative 3. And so now I'm going to graph that inequality. So my key number is negative 3, so one bigger would be negative 2, negative 1, etc., and one smaller would be negative 4. And so I put my, again, I haven't had anywhere we had a shaded in circle yet. Unfortunately, I don't know, I think that was just a mistake, but if this had an equal with it, we would shade it in. So since we don't, again, we're just graphing to the left because we want the values of y that are less than. So some of your work will be to graph. Again, shaded circle would be when there is a less than and equal underneath it, or greater than or equal to it, because it includes that point. All right, so now we're just going to practice the solving piece. I think you have the graphing piece down probably pretty good, although none of our examples had a colored shaded circle, so make sure you pay attention to that when you do your homework and check your answers. All right, so number 6 is pretty straightforward, so I want you to try that one on your own. Pause the video right now and then restart to see if you got it correct. So when you solve this one, you start by subtracting 4. That was adding or subtracting, so we don't flip the inequality. Whoops, this would be 9, sorry. And now I am dividing by -3. Remember, ding, 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 multiply or divide by a negative. We have to flip the inequality's direction. So this gives us x is less than -3. In the next example, we have some fractions, okay? You can do these fractions on your calculator now, so this shouldn't be a struggle, but I'm going to walk you through this one just to make sure. So on this example, again, my goal is to get x by itself, so I'm going to subtract 13. Again, I subtracted, but that doesn't change the inequality. It's only if I multiply or divide by a negative. So now I get 3/4 x is less than or equal to -15. So remember, on your calculator, your steps would be -15 divided by, and then you'd put the 3 divided by 4 in parentheses. And that would give you the correct answer. But if we do this on paper, just for review, remember what's going to happen is we are dividing by 3/4. And when we divide by a fraction, we keep, change, flip. So we have to multiply by the reciprocal of 4/3. So that's going to give us x is less than or equal to, a positive times a negative is going to be a negative. Again, that was a fraction, but that doesn't mean it's a negative number. So this is going to give me, I'm going to cross cancel here. Some of you use this strategy, some of you don't. You have a calculator, so you wouldn't need to, but I didn't grab mine. So this is going to give me -20 for my answer, final answer. All right, hopefully this is going fairly straightforward. We get into a couple more complicated ones here, and then I think what we'll do here is I will have you go ahead. You can try this one on your own, okay, and then check back to the notes and see if you got it correct. I'm going to do this more challenging one. The reason these are a little more challenging is because you're using the distributive property. And you will have to use it on both sides. So that's the first thing we have to do. That's going to give us 6x plus 15 is greater than, that just stays the same, 6x minus 16. Okay, now we subtract 6x from each side so that we can combine our x's together on the same side. But that gives us now 15 is greater than -16. That's weird, we don't have variables. Well, remember, sometimes we have no solutions to things. But in this case, 15 is greater than -16. So since this is true statement, then we say that this is infinitely many solutions. Okay? All right. So on this question, I again am going to have you try number 5 on your own and check back to the notes, and I will work through number 6 with you right now. So question number 6, we don't have any distributive property, so we need to get the r's on the same side. Now, if in these inequalities, probably the easiest things to do is to always make sure that you move the variables and make them on the left side. I know sometimes it's going to be easier to keep that positive, but with inequalities, this really does make it simpler. So that's going to give me -8r minus 20 is less than -4. I have to get my plain old, that's r is pretty bad, so I have to get my plain old numbers on the other side of the equation, so I'm going to add 20. And now that gives me -8r is less than 16. Now I divide by -8, and that gives me r. I divided by a negative, so again I have to flip it, and that is going to give me r is greater than -2. All right, now if you would have moved things the other way, it gets a little tricky because your r is on the other side. And if you're graphing it that way, you might want to, I would suggest for inequalities to always move all your variables to the left. And I know that when we do some more, you'll see some examples why that works out nicer. So another thing we're going to start practicing later on is writing inequalities and doing some word problems. Okay, I'm going to save these for a different time right now, but you can certainly look at the solutions on the notes to make sure that you're starting to understand this. I'm just going to do one right here. If we want to write an inequality to model that Bill is at least 21 years old, then Bill, his age, has to be greater than or equal to 21. So Bill could be 21 because it's at least, or he could be 22 or greater. So this is how you write sort of an inequality out of words. So like we'll practice these again when we get to some more applications. But that's where we're going to stop for day 1 for chapter 6, part B.